Hi, my name is Ane, and this is my partner Carl.
How's it going?
This is our video for Lab 3, and Carl will start off by explaining the low-pass filter.
Alright, so if we check out our breadboard here, we can see that in order to make the low pass filter, we have 1.5, the equivalent of a 1.5 kilo ohm resistor, and then a 1 nanofarad capacitor here. And then moving to the waveforms app, if we run it real quick, you'll see that around 95 kilohertz, that's when our gain is at -3 decibels. And so what this is pretty much telling us is that when you're over in the lower frequencies, the capacitor is acting like a wire, and so not offering much resistance to the circuit as a whole. And then once you get up into the higher frequencies, then it actually starts gaining charge. And if you check out here again, when the -3 decibels is here on the frequency, you can see that it's at around the inflection point of the phase, so then it's kind of starting to meet back up. And so now Andre will explain the bandpass filter.
Yes, the bandpass filter. The bandpass filter is basically an RLC filter with the inductor, which is given by this, and the capacitor, which is given by this. The inductor is 3. In this lab, it's theoretically 3.3, but it's actually 2.9 millihenries. And the capacitor is once again the 1 nanofarad, and the resistor we used in our circuit was 8.2 kilo ohms. So if we look at our frequency response for the bandpass filter, yeah, look at that. That looks great. So this peak value right here, this corresponds to the resonant frequency. So the resonant frequency is basically the frequency value where the impedance for the inductor and capacitor cancel out and all the impedance is real. So that's highlighted by this point here on our gain graph and at the inflection point on our phase graph.
Alright, that was lab 3.